So today we were solving problems, and here's one, probably the most difficult one of the four problems we looked at today about a pool table. We're told in the question that the pool table is always twice as long as it is wide. So whatever we have for the width of the pool table, the length is going to be twice as long as that. We've got to find out, if we take a look at the problem, we've got to find first of all, write an algebraic expression that represents the total cost for the felt and rubber for the tabletop. And then once we've done that, we're going to use that to determine the cost of materials for a top that has a width of 1.5 meters. So we're not going to go straight to the tabletop that's 1.5 meters wide. We're going to write the expression first. So the way we go about this is we ask this question: what changes in this problem? What is it that changes? Is it the cost of the bumpers? Is it the cost of the felt? Or is it the width of the table? Now these two things here do change, but they only change if the width of the table changes. If the width of the table doesn't change, then the cost of bumpers and felt would stay the same at all times. So we realize when we think about it, is the thing that's going to change in this problem is the width of the table. So that's what we want to use a variable to represent. Now we're told, so if we use W for the width of the table, W is a variable, it's used to represent the width of the table. We're told in the question that the length is always twice the width. So if the width is W, then the length will be twice W, or 2W. So now let's take a look at the cost of the bumpers. So the bumpers go around the edge of the table, so they go around here around the perimeter. So in order to find out how much length of bumpers we need, we have to figure out the perimeter. It's a rectangle, so the perimeter of the rectangle is the length of all the sides added together, and since we're using W to represent the width and 2W for the length, then the perimeter all the way around is going to be 6W in length, whatever W is multiplied by 6, that's going to give us the perimeter. So the cost of bumpers, which go around the perimeters, is going to be equal to the perimeter multiplied by the cost per meter, which is $2.25. And because we have a 6 here, we can multiply it by the 225, and we can write this as 6 times 225 is 13.5, so we can write it as 13.5 W. So that's for the bumpers. Then we've got to consider the felt, and the felt goes on the surface of the table here. So to find out how much felt we need, we're going to have to figure out the area, not the perimeter. So the area of the pool table, it's a rectangle, so area is length times width, so it would be W multiplied by 2W, which is 2W squared. Why is it squared? Well, if we think about the exponents here, there are no exponents, so we can think of them both being 1, and the product rule tells us that if we're multiplying together bases, powers with the same base, then we add the exponents together, so it would be 2W squared. The cost then of the felt will be equal to 2W squared, which is the area of the table, multiplied by the cost per square meter, which is $28. And again, we can multiply the 2 and the 28 together, and we get 56W squared. So I can combine these together now and say if I want to figure out the cost of the entire table coverings, then the total cost is going to be, it's going to be the cost of the bumpers here plus the cost of the felt. So we're going to combine these things together. And since we have an expression for the bumpers and an expression for the felt, We can add those together and that will tell us an expression for the total cost. So the total cost then is going to be 13.5W, that's for the bumpers, plus 56W squared, which is for the felt. And now that I've got this expression, this overall expression here, I can use this algebraic expression to find the cost for any pool table as long as I know W. So in part B, if W was 1.5 meters, the cost would be 13.5 times 1.5 plus 56 times 1.5 squared. And if I calculate that, of $146.25. It's important here to make sure that we have a unit. As you can see, there is a unit here. It's dollars, so we need to include that in our answer. So the important steps then in a problem like this is figuring out what is the thing that changes in the problem, in this case the width of the table, and then to write expressions like this one and like this one that represent the costs of various parts of the table, and then we can add those together to get an overall expression for our total cost. Once we've got that, we can use it to calculate the cost of tables of any width.